Alright, let's look at the homework 7.7, problem number 6. Alright, so we want to find the n value, so that guarantees that the Simpson's rule to approximate this given integral is accurate to within 0.00001. Alright, so let's look at that. Alright, so in order to use this error bound for Simpson's rule, we need to find the fourth derivative of the integrand. Alright, so here, this is going to be, I can't write on this, hold on a sec. Alright, so this is going to be our f of x. Alright. So let's say let's take the derivative. So f prime of x is equal to, alright, so I'll leave 7 alone here. Alright, derivative of e to the x squared would be e to the x squared. Then by chain rule, I'll multiply by the derivative of x squared, so it's going to be 2x. Alright, so we have that. Alright, then I'm going to just write it as, let's see, 2 times 7, so it's a 14. X e to the x squared. Alright, so then we take another derivative, f double prime of x. Alright, and I'm going to leave 14 out here. Then I'm going to use the product rule. So this is our first guy, and this is the second guy, right? Derivative of the first guy is 1, so you have e to the x squared plus x times, and derivative of e to the x squared would be, we just did it, 2x e to the x squared, right? So if you clean it up, you're going to get just 14 is outside. And you have, let's see, e to the x squared pulled out. Alright, so let's see, we took care of 14 here. And we pulled out these guys. Alright, so what's left is 1 from the first term. And then you have 2x squared from the second term. Alright, another derivative. So f triple prime of x. So this is going to be 14, just put it out here. Right? And the derivative of the first guy, derivative 1 is 0, derivative of 2x squared would be 4x. Right, times e to the x squared plus 1 plus 2x squared, and then derivative of that is 2x e to the x squared. All right, maybe I should put a bracket there, and here a bracket there. Alright, then we just have to clean things up a little bit. Let's see. So we have 14 here, and there's a 2 there, so I'll pull 2 out. So 14 and 2 on 28, so I'll pull 28 out. Alright. Then, let's see, and also e to the x squared out. Alright. So we have, so we took care of 14 and took care of those guys. Alright, so then 2 is pulled out, so you have 2x there. Alright, 2 is pulled out, so you have 1 times x, so it's going to be another x, so I'm going to just make that 3. And then x times 2x squared, so it's going to be 2x cubed is there. Right? Then we just have to take another derivative. So you have fourth derivative of x is going to be 28. It's just pulled out. Right, derivative of the first guy is going to be 3 plus 6, 3 plus 6x squared. Right, then the second guy is c to the x squared plus 3x plus 2x cubed times derivative of e to the x squared would be 2x e to the x squared. Right, then we just have to clean it up a little bit. So here, right, we have so 28 is out here. All right, then so we took care of 28 there, and then we're gonna pull out e to the x squared. All right, so we have e to the x squared. Alright, then you have, there's a 3, so then we have 3 here. I put that there, 3. Alright, then you have 6x squared, and then you actually have another 6x squared by distributing 2x to that guy, so it's going to be 12x squared. And the last one is, so we took care of that guy, and then distribute that, so it's going to be 4x to the 4th power. So 4x to the 4th power. Alright, so we got that. Alright, so that's the fourth derivative, and we want to find a k, which is the upper bound of absolute value of the fourth derivative. Right? And a is going to be, the interval is from 0 to 1. Alright, so we want to find the largest possible value that the fourth derivative of f of x can get between x is between 0 and 1. Alright, so since this is looks like this fourth derivative is an increasing function, the maximum value is going to happen at x equals 1. Right, so we have, let's take the absolute value of fourth derivative of x, f of x, is equal to, maybe I'll do that. Okay, so we're going to plug in x equals 1 because that's the largest value. So you have a 28 times 3 plus 12 plus 4 e to the 1. So, right, if you clean it up, looks like, let's see. So you have 3 plus 12 is 15, and then 19. So what's 28 times 19 would be, 8 times 9 is 72. And 2 times 9 is 18, so it's at 25, and 2, 8, so that'll be 2 here, and 3 here, and 5. So this is 532E. So this is our k value. All right. So let's put that and try to find n. So alright, so here using the Simpson's rule, error bound, right, k we just found out to be 532e, right, and b is 1 and a is 0 to the 5th power, and over 180 n to the 4th, right. We want this bound to be within 0.00001. Alright? Alright, so here, 1 minus 0 is 1 to the 5th. That's going to be 1, so it doesn't really do anything, so I cancel that. Alright, first thing is I'm going to take the reciprocal of both sides. then we have a 180 n to the fourth power, and divided by, and 532 e, right? So then reciprocal of that is going to be 100,000. So 100, let's see, 0, 0, 0, 0, 0, right? If you take the reciprocal, we have to change the direction of the inequality, so it's going to be greater than or equal to, right? Then we just need to get rid of 180 and the 532e. So we can do that by simply multiply by 532e over 180. And then we get x to the fourth is greater than or equal to, let's see, 532. Then I have to put the 5 zeros. 1, 2, 3, 4, 5, and e over 180, right? You can knock off one of the zeros, so I just knock off one of the zeros. And then we can take the fourth derivative of, fourth root of both sides. So you have n is greater than equal to fourth root of 532, and you just have to put the 4 zeros, e over 18, right? So let's compute this value. All right, so we want to compute, let's see, parenthesis, 532, and you have 1, 2, 3, 4 zeros, times e, so here's e, I just put 1 there, right, and divided by 18, and then we just have to raise it to the 1/4 power, right? Then hit enter. Alright, so this came out to be 29.9, so this is going to be about 30. So this is about 30. And luckily, this is even number. Alright, so we're going to just type that number in. Alright, so let's check the answer. So we need 30 for n to guarantee the accuracy they're looking for. Alright, so let's submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.